So, hello everyone. We're gonna start the session now. So, first of all, very good afternoon to everyone. A very warm welcome to all of you to the introductory session for Snowflake Educational Series that is powered by BluePy. My name is Varun. I'll be your co-host as well as the moderator for the session. So, without wasting much time, I'll introduce the speaker to the session. The speaker's name is Mr. Divyadas. So, Divya is working as a technical lead with us, and he is catering majorly, data science as well as data warehousing projects. So, this is so maybe I would request Divya to share the stage with me. Divya, you can take over.
Hi everyone, welcome and good afternoon, and thanks Varun for the introduction. First of all, thank you very much for joining in. So this is the first session of Snowflake web series, educational series, where we'll learn the basics of Snowflake and we'll do a live demo of the Snowflake as well. One important point before we begin, you should be able to see a Q&A tab towards your right. Feel free to post your question there during the session and we'll take them up towards the end of the session. All right. And before we start in, let's talk about who all can benefit from these educational sessions that we are taking. So it can be anyone who wants to learn cloud data warehouse implementation in general, or it can be anyone who wants to use Snowflake as a data cloud platform and want to learn about all its features that are available out there. Or you can be someone who's not happy with your current data warehouse implementation and are looking for a more scalable solution out there. Also, I mean, lastly, someone who's looking for a complete data cloud platform for their organization will also benefit from these sessions. I mean, with that in place, let's talk. Uh, I'll give you a quick intro to the points that we are going to discuss in our today's session. So the very first point that we'll see is why do we even need a warehouse? Post that, we'll see what are the different cloud offerings that are provided by Snowflake in its data cloud platform. That is how what all your organization can do over Snowflake if you choose it as a data cloud platform. Once we are done with these 2 points, we'll go and see the Snowflake architecture in more depth. How is it different? How is it helpful for us? With that much already done, we'll have a demo of Snowflake, and post that we'll see some features that are unique to Snowflake in terms of how they are implemented and how they make Snowflake fast. So in brief, we are going to cover these 5 points. So we do have a lot to cover in 1 hour. So and the very first point that we'll see is why do we even need a warehouse? And to understand that why do we need a warehouse, let's first see. I mean, what is a warehouse? And this is for those who are not already aware about it. So a warehouse is a central repository of data from disparate sources within your organization, and you use it for data analysis and reporting purpose. And also a data warehouse is a very core component of BI, business intelligence, within any organization. So it's a central repo of data and you use it for analysis and reporting. But if you would know that organization already have OLTP system in place. OLTP system are nothing but the transactional system behind your application. I mean, they store all the data. Let's say there's a banking application, and the data of the bank ultimately is being stored in a system, and that is OLTP system. So you already have a system which is storing your data. You could say that you can go to that system and run your SQL queries there and be done with your analysis. Why do you even need a separate system? Pay for it, of course, to do your analysis. So the main reason for that is that OLTP system are designed for massive parallel transaction processing. I mean, very they are optimized for writing the data and not getting information out of it. If I have to talk about the storage as well, the storage in OLTP systems are row level storage, whereas in a system which you would want to use for your analytics purpose in big data environment, you would want a system that is read optimized, and the storage there should be columnar and not row level, and that is what an OLAP system is. An OLAP is an online analytical processing system, and a data warehouse is based on OLAP system. So OLAP system is a system which is read optimized, and data warehouse is a system where your data is collected from varied sources and it is based on an OLAP system. Also, one more reason is that within any organization, you would of course have more than one OLTP systems. You will have 10, 15, 20 databases. If you want to do some analysis across these databases, you would want to join some tables which are available in 4 to 5 tables. You would need a central storage where you have all the tables available and you are running your queries over them. So yeah, I mean, that is the need of a data warehouse. So with the need of warehouse already agreed upon, let's see the implementation of data warehouses. I mean, data warehouse can be implemented on cloud and on-prem as well. But there are certain limitations when we go with the on-prem implementation, and the main challenge that I see is the scalability. I mean, on-prem solutions are very difficult and costlier to scale. There you are also responsible for installing and maintaining the hardware and the software bits as well. And plus, if you were to choose an on-prem implementation, the upfront cost that you have to pay for implementing your data warehouse is quite large. I mean, you have to pay for the hardware, for installing the software, for choosing a new software. It's quite a bit if you compare it to a cloud warehousing implementation. So these were the limitations. If I have to talk about cloud data warehousing, they are very easier to scale. And if I have to talk particularly about Snowflake, it has a unique architecture in cloud, which we are going to talk about in depth in the later slides, which is very easier to scale. And also one point was scalability. The other one was the installing the hardware and the software bits. And most of the time of a database administrator, if you have an on-prem implementation, goes into maintaining these two things only. They optimize the query, they take care of hardware and the software. But Snowflake is a complete SaaS offering. You need not worry about any software, any hardware. Snowflake takes care of all the things. And the third point was the upfront cost. So that is also very minimal in Snowflake. You only pay for the storage and the compute. Storage is all the data that you have stored in Snowflake, and the compute is, let's say you run a query, the query is going to run somewhere. So you pay for that compute only for the time till you are using the compute resource. So let's say in a day you only use the compute resources for 1 or 2 hours. You will only pay for 1 or 2 hours, not for the rest 22 hours. So that's a very big advantage as well. With that, we have seen that why do we need a warehouse and the differences between the cloud and the on-prem implementation. So now it's time to get introduced to Snowflake in more depth. So just a second. So Snowflake primarily began as a data warehousing company, cloud computing based data warehousing company. It was founded in 2012, and then it was publicly launched in 2014 after 2 years in stealth mode. Now in 2022, if I have to talk about Snowflake, it has various different capabilities apart from data warehousing, six to be precise, which they call data loads, to cater to your organization data needs in cloud. And also one more point that I would like to mention is that Snowflake is one of the first to introduce separate compute and storage in the cloud. Uh, by separate compute and storage, I mean that your compute and storage are different, and we'll see these 2 points more in depth when we go to the uh, architecture bits of Snowflake. The picture here on this slide describes the 6 data loads that I mentioned just now. Uh, okay, is it? It seems there's a technical glitch. Let me reshare my screen again. Okay, I hope slide number 2, introduction to Snowflake, is visible to all of you right now. I think it was not shared previously. So yeah, so there, where was I? Yeah, there are 6 data loads to be precise in Snowflake. One, of course, as you see in this picture, is data warehouse. Apart from it, there is data lake as well. So you can set up your low level transactional table in Snowflake as well. So what this gives you the advantage of querying your lowest level table from Snowflake only. That is, they are available on the same platform where you have your data warehouse implemented as well. Then you have data engineering workloads as well. You can set up your data engineering pipeline in Snowflake as well. Then there is a data load called data exchange. This is a unique feature to Snowflake. It basically means that if there are two companies which are both using Snowflake, company A and company B, uh, if company A wants to access the data of company B to do some analysis, they can do that directly over Snowflake. They did not create any separate APIs or physically share the files. They just create a data share. One company becomes the provider, the other one becomes the consumer, and they just share the data between them. And one more point is that the physical storage of the data still remains with the primary company only. You are just given the access of the data and not the physical aspect of the data. So I mean, let's say I I am sitting here in Mumbai region and I want to access someone's data who are also on Snowflake in US, and so I can basically just easily access their data using this feature and be done with my analysis as well. Then the fifth data load is data application. What this basically means is you can have Snowflake as your data layer in your applications. Then the last one is the data science workload. So Snowflake provides Python and PySpark native connectors, which you can use to train your models by having your data already be present over the Snowflake platform. So these were the 6 workloads of Snowflake. At the left and at the right, you can see the data sources and the data consumers. Data sources can be your OLTP databases, your ERP application, your web logs. All can be stored into the Snowflake, into your data lake, which is already on Snowflake, and then you can create a data warehouse also on Snowflake. To the right, you have data consumers. You can use, the data that is present in Snowflake for operational reporting, for ad hoc analysis, for real-time analytics, and then, as I said, for data monetization as well. Now you can see the picture of three cloud providers here: GCP, AWS, and Azure. Uh, the reason for that is Snowflake is a cloud warehousing solution, and it uses the resources of cloud providers to give you the software. So, and it can be any one of them. It can be Google Cloud, AWS, and Azure. The compute and the storage are of either of these three. And also, I mean, you can have one account of Snowflake for one company in Mumbai region, AWS Mumbai region, let's say, and then you can have a secondary account of for your company in, let's say, GCP Singapore region. So, I mean, Snowflake provides you with cloud agnosticity like no other software. So now we are done with the general overview. It's time to get a bit more technical and see Snowflake architecture and its advantages. So Snowflake architecture is what we call as multi-cluster shared data architecture, and its family consists of three layers: storage layer, compute layer, and services layer. The storage layer, as its name suggests, is the layer where the data is physically stored. And of course, as I said, the storage is used of the cloud provider. The query processing layer consists of multiple virtual warehouses, and each virtual warehouses, to be precise, is just a combination of clusters. So within a virtual warehouse, you will have different clusters as well, where your actual query will run. So if you fire a query to do some analysis, let's say get the sum of salaries of all your employees, I mean, data will be fetched from data storage layer into the virtual warehouse. The query will be computed and you will get the result via query processing layer. Then there is cloud services layer. The use of cloud services layer is to stitch all the Snowflake functionalities together. Uh, 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 all the infrastructure management, get where the data is stored, all of it is carried by the cloud services layer. So this was a general overview. Let's see each of these three layers in more depth, and we'll start from the bottom, from the storage layer. So Snowflake storage layer is a bit unique. I mean, it's a hybrid of shared disk and shared nothing architecture. So if I have to talk about first shared disk and shared nothing architecture, by shared disk architecture, I mean is that your multiple machines are using the same storage, and this is achieved in Snowflake by you had your separate compute layer, and then you had your separate storage layer. All the virtual warehouses will use the data that is stored in storage layer. If they have to get access to the same table, then also they will go to the storage layer only. And if two virtual warehouses need to access same data, they can get it without any resource contention as well in the same time. So this is how shared disk architecture is maintained in Snowflake. By shared nothing architecture, it means that, let's say you have five node, let's say one node is one machine. In every machine, you store a separate portion of your data. So in this way, I mean, you do not have to go to a separate layer to get the data, and the query processing is faster. How this is achieved in Snowflake is you have your query processing layer, and it consists of multiple virtual warehouses. Each virtual warehouse is nothing but a combination of cluster, and a cluster is nothing but a machine. So if you fire a query and your virtual warehouse is in suspended state, that is not started, the data at the first time for a table will be accessed from the storage layer, and then it will be stored in the virtual warehouse. Now, if you have, remember I said that you only pay for the amount of time you are using your virtual warehouse. Let's say you have auto suspend feature. There's an auto suspend feature for virtual warehouse that if no new query comes to a virtual warehouse for, let's say, 10 minutes, it will shut down immediately after 10 minutes. But in between those 10 minutes, the data is stored in the local SSD storage of the virtual warehouse. So if you fire a new query, let's say after 5 minutes, which needs the same data, then Snowflake will not go to the database storage layer, and it will directly return you the results for your query from the virtual warehouse only, because virtual warehouse are nothing but a cluster of machine, and they have their own local SSD storage as well. So with that, we are done with the storage layer. Now we'll see the query processing layer, where the actual processing is done. uh, as I said, the processing layer consists of multiple virtual warehouses. Now, each virtual warehouse further contains a combination of clusters. Now, when you create a warehouse in Snowflake, you need to specify two things. One is the cluster size, which you can see on the screen in the drop down list, is a t-shirt sizing starting from extra small to 5x large. Extra small is the least powerful, and the 5x large is the most powerful. You pay the least for the extra small, and you pay the most for the 5x large. So you select the cluster size, and then you specify the minimum and the maximum cluster count as well. You can specify the minimum and maximum. Let's minimum as 1 and maximum as 5. So let's say you create two virtual warehouses, and let's understand this with an example. You have two workloads. One workload is of heavy ETL. You have to process a lot of data and then save it back into your warehouse only. And the second workload is you just need to do some analysis over some tables uh, and be done with your analysis. So for the first workload, what you will do is you will create a virtual warehouse of size extra large. This is the virtual warehouse one in the slide. And then you choose maximum, minimum and maximum as 1 or 2. So this cluster 1 and cluster 2 will be of same size, extra large, extra large. And if the query that you are firing, the ETL workload that is happening, if it does not require two cluster, Snowflake will use only one. And if more workload comes on, then there is automatic scaling in Snowflake, and you will have two clusters up. Same for your analysis workload is your virtual warehouse 2, and you have created is of the size extra small. So this was the processing layer, where you actually create your virtual warehouse. Now let's see and the functions of the query services layer, where actually when you fire a query, it first hits the services layer. And let's see all the functionalities and how it binds the storage and the compute layer together. So the main functionalities of a services layer are authentication. So if I fire a query, Snowflake authentication, Snowflake services layer first determine my identity. There is access control as well, and that is rule based to be precise. So it will check that whether do I even have the access, the required privileges to access the required data that I've queried, and whether do I have the privilege to perform the specific operation that I have performed. Let's say I perform an operation of delete. It will check that do I have the delete privilege or not. Then there is infrastructure management. As I said, Snowflake is a complete SaaS offering. So the virtual warehouse that you created, you just needed to specify the size and the minimum and the maximum count. If you fire a query and the cluster is not up, starting it and starting it, running the query over it, that is all taken care by the services layer. Then there is metadata management. Metadata management, I mean, is responsible for features that are, I mean, quite unique to Snowflake. These are zero copy cloning, time travel, and that's a very cool name. And then there is data sharing as well that we have already talked about. So zero copy cloning and time travel we'll see in the last slide, where I'll be talking about some of the features, some of the unique features of Snowflake. Then the last one is query parsing and optimization. This basically means that when you fire a query to Snowflake, the query service, it first goes to the query services layer. It will first optimize your query, write a optimized query plan for it, and then it will basically forward your query to the virtual warehouse. If the virtual warehouse is not up, it will start it. It will give the query to virtual warehouse. Virtual warehouse will access the data from the data storage layer, and then it will give you the query results back to the services layer. So we have seen all the three layers in detail, but now it's very important for us to discuss that how this multi-layer architecture and shared disk architecture that Snowflake has, how this architecture solves the problem of scalability which we were facing in on-prem solutions, and how having this architecture is actually beneficial for us. So, which brings us to this slide where we are going to talk about performance and scalability. So, how Snowflake solve the scalability problem? To understand that, first let's see that what type of scalability do we need in a system. There are two. One is horizontal scaling and one is vertical scaling. By horizontal scaling, I mean, let's say if you have two nodes which are running in parallel to cater to your needs of your query, you would want to scale horizontally and create two more or three more or five more of the same size, but you have multiple uh, machines of the same size to cater to your needs. When this helps is, let's say if you have multiple concurrent users who want to access your data warehouse, then at that time you would need multiple machines as well with I mean one for multiple requests to cater to the needs. This is basically a scenario, let's say in Monday mornings when people come to your data warehouse to open their reports, or in end of the quarter they all want to access the reports. So if at that point of time your data warehouse implementation is not able to scale, they would need to wait for hours, and they would just stop using your system. So this was horizontal scaling. Vertical scaling is you increase the size of your machine only. That is, let's say if you have this is just a generic example. Let's say you have a machine of 32 gigs RAM. You would want to increase the machine strength from 32 gigs to 64 bits. So this is vertical scaling. Now, how both of these are achieved in Snowflake. So as I said, and as you can see in this picture, you specify the minimum and the maximum number of cluster when you are creating a warehouse in Snowflake, and you just name it. You can specify the minimum from 1, and the maximum you can specify till 10. Uh, Automatically, if there is more load, Snowflake will create more clusters from 1 to 2, 2 to 3, 3 to 4 within seconds. You will not even feel it. And when there is less load, it will shut them off accordingly as well. Next is vertical scaling. That also you can go and change the size of the cluster as well. So let's say you had a cluster of size extra small. It is in running state, that it is catering to the needs of the users. But at that point of time only, you change the size from extra small to extra large. What Snowflake will do it, let's say there are 5 queries that were already in queue, and three are running. So the 3 that are running on the extra small will keep running on the extra small, and these 5 will go to the extra large one. And this all will happen behind the scene within seconds. You will not the user will not even feel it. So this is how both vertical and horizontal scaling are achieved in Snowflake. uh, so with that, we have covered a lot of theory. Let's go and do some hands-on by having a demo of Snowflake. I'll quickly share my stop share and share the main screen. Okay, there are some questions as I can see. Let's take the questions before we move on to the demo. One is, what happens if I specify the minimum and the maximum cluster size as the same one? Okay. So what this basically means is, as soon as one query comes to your cluster, if the minimum and maximum you have specified as 5, all 5 cluster will be up. This is basically a scenario when you, so yeah, all 5 of them will start at the same time, and you would want to do this when you know that you are going to get a lot of concurrent queries beforehand. So yeah, that can be done. uh, okay, let's move on to the demo first, and we'll take the rest of the questions in the interest of the time towards the end of the session. Let me share my screen. Hmm. So this is the UI of the Snowflake platform. Uh, at the top here, in the menu section, you can first of all see databases. Uh, this is basically where you'll see the list of all the databases that you as a user of Snowflake has access to. Right now, I have access to 1, 2, 3, 4, 5 databases. Then there is data share. Data share is nothing but the point that I mentioned of two companies, and they being able to access their data remotely from their Snowflake UI. If I have to give you a real world example, then you can see this second database called Snowflake. So this is not a database that is created by me. This is a database that is pushed to all Snowflake accounts, and it contains various schemas which contains the usage stats of Snowflake. You are using Snowflake, how many users have logged in, the query history, and all that is pushed to your Snowflake account by Snowflake. So it's a data share pushed from the Snowflake company only. Then there is marketplace. Data marketplace, this is for data monetization purpose, and of course, there are some databases that are available free of cost as well. If you create a data share, it will be available, and if it is on the data marketplace, you can go and access from data marketplace. Warehouse, if you click here, you'll see all the data warehouses that you have access to, and of course, you can create a data warehouse here as well. Then the next one is the worksheet. So Snowflake has concept of worksheet. The screen that you see here, with my SQL queries is what is known as worksheet. You can basically do your analysis, run your SQL queries in a worksheet. You can increase the width as well here. Then there is the history tab where you get the history of all the queries that have been done on Snowflake. You can go into a query ID and see the stats of the query as well. So that was and of course, all the database that you have access to, you can see in this left database object panel as well. If you click on them, the database is further segregated into uh, schemas, which is nothing but a combination of primarily of table and views only. So in the demo, let's consider an example that you are a data analyst and you have been asked by your manager to do some analysis over some data that is present on your let's say AWS S3 bucket. So I mean the data is not already present on Snowflake in the Snowflake storage layer. So what you will need to do is uh, you will need to create a database where you want to store that data from AWS S3. You would need to create a data warehouse with where you would want to run the query for your analytics purpose. So I mean that's the motive of our demo. So let's start with it. First of all, we'll create a database. We'll create it using a SQL command. And yes, for the purpose of the demo, I am using the publicly available Titanic dataset. I run the command create database Titanic 2, and here at the bottom you can see that the Titanic 2 database has been created. The right panel you can see here Titanic 2 is being shown in the list. Uh, so the database creation is done, but the data is present outside of Snowflake environment. So if you go into database in Titanic 2, uh, to load in data into the Snowflake, you need to create an external stage. That is, the data is external to Snowflake, and you need to specify the location of the data, and that is the location of your AWS S3 bucket. To create a stage, I've already created it in the Titanic database uh, in the stages. To create a stage, you click on create, you choose the cloud provider of your choice. And one more point, I mean, the outside data that is outside of Snowflake can be in AWS S3, Microsoft Azure, or GCP. You are free to choose wherever your data is, and it is that easy to bring in the data. You click on next. You specify the name of your stage, uh, the schema name within the database you want to create or external stage in. You provide the URL of your AWS S3 bucket, and you give the access key and secret key ID. And with that, you are done. This is the stage that I had already created. Once a stage has been created, you can use the command list underscore the stage name to list the contents of the stage. It says Titanic 2.public Titanic state does not exist or authorize. So if you can see in the top right corner here, there are 4 options. It says that I am an account admin and that I am using a warehouse named demo and that I am using a database named Titanic 2. But I did not created any external stage in Titanic 2 database. So I need to create Titanic database in which the stage is actually created. Also, we skipped the part of creating a warehouse. So let's go and see that as well. To create a warehouse, you just need to click on create. You give the name of the warehouse, let's say demo 2. You select the size, let's say medium. You select the maximum number of cluster as 5. You choose the minimum number of cluster as 1. Scaling policy, let's ignore it for a second. And then auto suspend is 5 minutes. So if no new work come for 5 minutes, the warehouse will shut down. And I click on finish. And with that, if you can see demo 2 data warehouse is already created. Consider a scenario in on-prem where you need to create a new virtual warehouse or you need to even scale it. Within clicks, you can create a new warehouse, and this is how easy it is. Yeah. As I talking about the stage, to list the contents of the stage, when I say stage, it's the contents of the remote data that is present on your AWS S3 bucket. you can see that there is a file, there is a CSV file and only one file of size 61 KB present in my AWS S3 bucket. So if you had inside Titanic folder in your AWS S3 bucket, if you had, let's say, five CSV files, you would have seen 5 rows here. Once that is done, you just need to specify the schema of the table, uh, which we are going to do right now. But I think any database already has a hash, so we need to drop it first. As you can see, the table has been dropped. A new table with 0 rows have been created. Now to load in the data from external stage to my table that I have created in Snowflake, I need to use one command known as copy command. So I copy into my table name Titanic underscore P from my external stage. And I'm done. The data has been loaded. Now I can start with my analysis. Let's say I fed this query, select star from my table. So this is how easy it is in Snowflake to create a data warehouse, to create a database, and to get access that and to access data that is not already on Snowflake, and start your analysis over it. That was the content of the demo. Let's move back to our slide. I'll share my slide screen again. All right. So we are done with the most part of our session today. We saw why do we need a warehouse. We saw the capabilities that Snowflake offers as a data cloud platform. Then we saw the Snowflake architecture in depth and how that architecture helps in scaling as well. Then we are done with our demo as well. The last point that we are going to cover in the today's session are the features that are unique to Snowflake in terms of how they're implemented. And the first on that list is micro-partitioning. So before going into this feature called micro-partitioning, let's first talk about what is partitioning and why is it even done in warehouses. So it's not like partitioning is only done in Snowflake. It's done in all the traditional warehouses, but let's see how it is implemented in Snowflake. So partitioning you need when it helps to scale your data warehouse by dividing your database objects into smaller pieces. So let's say you have a table of size. This is just for example. Let's say you have a table of 10 TB, and that 10 TB of table you have partitioned into 10 10 pieces. So now you have your table distributed into 10 partitions. So if you are going and every data warehouse maintains information about the partition as well as to uh, the start and the ending value of the column in that partition and the unique value of that column as well that is stored in that partition. So if let's say you fire a query over this multi-terabyte table of 10 TB size, and your data warehouse already know that I only need to go to the partition number 2 to compute the result of this query, because it saves metadata about each partition, then you would of course benefit from, I mean, not scanning your whole data of 10 TB and just 1 TB. Uh, yeah, I mean, I hope partitioning is clear. So now, how partitioning is done in traditional warehouses? It's done basis the column level. I mean, you specify the column basis which you would want to partition your data. Let's say you specify column date, or by year, by date, or a type column for that matter, or a combination of these two. uh, Traditional warehouses used to partition your data based on the value present within these column. So for each unique value, you would have separate partition. So the main issue with this is the introduction of skewness within your partition. So let's say you have selected a column to partition by, and one particular value is repeating quite frequently in that column. Then the partition, one of the partition will have a lot of data, and some of the partition will have very few data, very less amount of data. So this beats the purpose of partitioning altogether, because one of the partition has most of your data, and whenever a query comes, you are going to that partition again and again, and searching the whole partition. And with Snowflake, with micro partitioning, how Snowflake does it is, it as soon as you save your data in your Snowflake, it creates partitions of size 50 MB to 500 MB, and then it saves it. So you have multiple partitions within Snowflake ranging from size of 50 MB to 500 MB, and all your data is stored in that manner. And then Snowflake also contains metadata about each and every partition. That is, let's say if there are 3 unique columns, type, name, country, then the unique values contained within each partition, and the starting and the ending value of contained in that column in that partition. So when you fire a query, it knows which partition. Let's say if you have 10,000 partitions, it knows which 500 partitions I need to go and search to get you the required result. So this was micro partitioning, but there is one more feature in Snowflake which is called clustering, uh, which when used with micro partitioning further optimizes your query performance. So clustering is nothing but ordering your data when you are saving it. So that is, let's say in our previous example, Snowflake created 10,000 micro partitions. And within that, when you fired a query, it was going to 500 micro partition to cater to your query needs. But with clustering, what you do is you order by a specific column. Let's say there is a type column, as you can see here in this picture. There is a type column which contains, I mean, value ranging from, I can see here 1 to 5. What you basically do is you order by this type column when you are storing the data into Snowflake. You can do it afterwards as well. But if you do this, uh, if you order by this column, the all the column which have value of 1 will be stored in one partition. All the column which have value of 2 will be stored in uh, the second partition. So it's not like a row with the value of 1 is stored in micro partition 1 as well and micro partition 2 as well. So Snowflake would need to search very less number of micro partition to cater to your query needs. So this concept is called query pruning, and this is done excellently in Snowflake. And as to how clustering is done in Snowflake, it's automatic in nature. By automatic, I mean is you just need to specify the column by which you would want to cluster, that is order by your table, and behind the scenes Snowflake determines that whether there is a need uh, to cluster your already present table or not. So if you are firing a query and Snowflake sees that there is a need to cluster the table behind the scenes without you specifying it, it will automatically recluster your data. And while reclustering, you would still have access to your data. Also, this clustering scenario, this is all only needed to be precise when you are dealing with data in multi-terabyte range. If you are dealing with MBs or GBs of data, you don't even need it in Snowflake. So we are done with micro partitioning and clustering. Next up in our list are three more features, which are called zero copy cloning, time travel, and failsafe. Zero copy cloning and time travel, I specified at the start that they are handled by the services layer. So let's have a look at them as well. Zero copy cloning is if you copy your database, let's say your database is of size 3 TB, and if you copy it in Snowflake, Snowflake does not actually creates uh, a physical copy of your database. So you had a database name database production, and you want to do some QA, and so you want a copy of this database. So what you would need to do is you need to create a copy of it, because you cannot go and test the production database. So you create a copy in Snowflake. So when you create a copy, uh, physical 3 TB of data is not created, and this copy, the QA database, will be created within seconds, because no physical data has been created. And if you were to go and change some table of this QA database now, only the change table or the change rows from the original production database, that is stored by Snowflake. Rest all, uh, you need not even pay for it, and the copy is created within seconds. Consider a scenario in on-prem. Uh, these are the activities that happen in night or on weekends, where you take a copy of a production database for a backup purpose, for a QA purpose. This is how easily they are handled in Snowflake. Time travel. Next up is time travel. So time travel uh, is that as the name suggests, you are able to go back in time, but this is with respect to your data. So Snowflake offers a time travel option from 1 to 90 days. What this basically means is, let's say right now the time is 2:55. Uh, let's say I have a table with 10 rows right now, and at 3 p.m. I appended 5 more rows to the same table. But later I found out that these 5 are junk rows, and I want to go to a state of my table that was at 2:55. So Snowflake keeps a track of all the changes that you are doing within your database. You are performing any DML operation. Snowflake keeps a track of all of these, so you can go back to the previous version of the table. So you can either go by the time as well, by specifying that I want to go back to a time of 2:55 or by 2 hours back, or you can go by query ID as well. As I said, every query that you run in Snowflake that has a query ID, you can just get the query ID and then go to a state before that particular query was run. This is particularly very useful for developers when when we fire a delete query or we drop some database. You can readily go back to a previous version of the database object. Next up is failsafe. Failsafe is a feature more from the perspective of DR, that is disaster recovery. With failsafe, Snowflake keeps a backup of your data within its environment. When I say within its environment, it's separate from the database storage layer that I was talking about. I mean, it is the storage layer only, but let's say you have specified the time travel period is as 1 day, and your table, the contents of it, if you want to access from day before yesterday, that because you have 1 day time, because 1 day time travel is already available with you. But if you want to go to a state a day before yesterday, you can use the field save option and get the content of the table directly from Snowflake. But with field save, you would need to approach the Snowflake company to get your data. You do not have direct access to it, but from a DR point of view, this is a very good option. Uh, the last in our list is caching. Uh, so there are two type of caching in Snowflake, and yeah, I mean the caching is used to make Snowflake fast or any system fast. So the two caching are result cache and local disk cache. By result cache, what I mean is, uh, if you fire the same query in Snowflake, exactly same query, uh, then Snowflake will de- deliver the results to you uh, from the result cache. That is, the same query won't be run again. You would not even need to pay for it. And this is taken care by the services layer. Remember, there are three layers, and in this diagram, you can see there is in the left one, there is services layer, then there is compute layer, then there is storage layer. And to the right, you can see the result cache is being catered by the first layer. So if you fire the same query, the services layer will know that this is the same query, and it will directly give you the results, uh, condition that the data has not changed. So if you are accessing a table of multi terabyte range, and the query takes around 15 to 20 seconds to run, if you fire the same query, you will get the results in milliseconds. Local disk cache. So local disk cache is implemented by the compute layer in Snowflake. Uh, so as I said, the compute layer is nothing but a combination of virtual warehouse, and they also have clusters within them, which are nothing but machines, and they have SSD storage. So they also have their own storage. So till the time they are up, they store data within themselves as well. So if a data is already present in the local disk cache of the query processing layer, then Snowflake won't go to the storage layer, to the remote disk, to access the data. And this, I mean, this architecture, working in this fashion makes Snowflake fast as well. With that, I mean, let's go and see result cache and local disk cache in action, and that will mark as the end of our today's session. Let me just share my screen. Okay, so the Snowflake screen is up. To the right, you can see here that the warehouse that we are using, all of them are in suspended state. The database is Titanic. If you remember, during the last demo, I fired this query: select star from Titanic public Titanic underscore p. If I fire this query again, uh, do take a note that all the warehouses are in suspended state. I have fired the query and I got the results back, but the warehouses are still in suspended state. This means that you are getting results back directly from your result cache. To further see this point, let's see this query. The query at line number 27. We are getting the sum of the age from our table. If I were to fire this query, took longer than expected, but let's go. If I open the query history, and there is an option to see the query profiling, you can see that most of the time that is spent to fire this query has been in the IO. It is 100% of the time is uh, is under IO. Bytes scanned are quite less, and the percentage scanned from cache is 0.00%. Now, if I were to fire the same query again, I got the result in 36 milliseconds. And we can go and check the query profile again. And you can see that IO time is not listed here. The other basically means that the time it took, that is 38 milliseconds to get the results from your result cache. With that, let's take a look at local disk cache. So our warehouse is already up. Oh, and the result cache, as I mentioned, you can use some other warehouse as well. Let me choose analytical warehouse. And if I query the same query there as well, then also I can get the results 21215, and the warehouse is still in suspended state. Now let's take a look at the local disk cache. So now I'm changing the query a bit from sum to average, and I'm pairing the query. It gave me the results in 100 millisecond, massively less from the time it took for the sum command, because there it had to first go to the storage layer, get the data from there, push it to the compute layer, and then compute it and then give you back the results. If I have to, we can have a look at the query profile. There, as you can see here, most of the time still went into the IO only, but the percentage scanned from cache is now 100%. And this is the cache which is referred to as the local disk cache of the warehouse. So with that, we have taken a look at the result cache and the local disk cache, and how beautifully it is maintained in Snowflake, and how it makes Snowflake as your warehouse system quite fast. So thank you so much for joining in. With that, I will end my presentation. Uh, if you have any more questions, oh yeah, I mean there are some questions, so let's go and take a look at them. Uh, there is a question by Tanika, which is, how are data engineering workloads handled in Snowflake? Uh, there are two ways basically. Uh, you can write SQL scripts as well within Snowflake to do easier data engineering workloads and use SQL directly from there. Apart from it, Snowflake has a partner connect feature as well, where Snowflake has partnered with multiple technology based companies which are into ETL, ELT, BI, some of which I have to name are Fivetran, or from BI it's Tableau, Power BI. So they are integrated within the Snowflake environment, and you can use them for your engineering workloads. Let's pick a few more. Uh, what is the difference between standard and economic scaling policy, from Ayushi? Okay, I did not cover this, but standard and economic scaling policy is, as I said, it is very easy for Snowflake to scale horizontally. Standard standard policy is, if Snowflake knows that for the next, I mean, if there are more than 6 queries in the queue, the Snowflake will automatically spin up one more cluster to cater to your needs. So that is a standard scaling policy. By economic scaling policy, it will wait and see that if the current warehouse can complete the workload in less than 6 minutes, it will not spin up one new cluster. If the wait time is more than 6 minutes, then only it will create one more cluster. So the economic is quite cheaper than the scaling policy, but it is basis on the workload type and your choice as a data engineer as to what you would want to need, as to what you would want to use. With that, I'll end my presentation. If you have any more question, you can reach out to me via my LinkedIn, or you can mail us at BluePie as well. And one more thing, there is a feedback tab at the top right corner. So feel free to give us your feedback. It will help us in improving our further sessions. Thank you very much. Have a nice day.
All right, so I'm on screen. That means we have filled up the feedback forms. So it was a very informative session, and thank you. I really appreciate Divya for sharing that information. So the feedback, why it is important, because this will play a vital role in order to get more constructive as well as educational content, right? So now just to wrap up, thanks for joining in. This was the first introduction session. With time, we will come up with multiple sessions that will be more educated towards the Snowflake educational series that is powered by Blue Thank you.